Hey guys, this is Dan, and in this video I'll be going over discussion number 2 on recursion, specifically 2.1.2, which is Pascal's triangle. So why don't we get started right away? I think the most important thing about this question is figuring out what Pascal's triangle actually does. So over here, you guys could just read this, but I'm gonna try to show you guys what Pascal's triangle really is. So I pretty much just wrote this helper function, draw Pascal, to draw out Pascal's triangle for you guys, and let's take a look at what it actually does. Okay, so as you can see in row 0, there's 1 1 and the rest are zeros. In row 1 there's 2 1s, and then it keeps on getting longer and longer. So where do these numbers actually come from? Well, let's start with this extra 1 here. So this extra 1 actually came from the sum of these two numbers right here. So the row above it, you look at the column before it, and you look at the column right above it. So 1 plus 0 is 1. And then if you pick any arbitrary point here that's within the triangle itself, such as this 10, it will be from the row above it and these two elements right here. 6 plus 4 is 10. Over here is 21, and then you can see that over here is 6 plus 15. So from that, it's kind of hard to write a program that does this, but when you think about it recursively, then it's pretty natural. So why don't we get into code writing right now? So here, let's just start writing some code. So as I said before, if I'm trying to get, like, let's say this 15 value over here, I will want to look at this value 5 and this value 10, sum them together, and then I'll look at the 15. But the question is, how do I get these 5 and 10? Where do they magically come from? Well, if I believe in recursion, and I believe that if I recursively call this function, it'll give me the right values, then I could just kind of just pull this out of nowhere. So let's start with 5. Where is 5 actually? Well, it's one less row, and it's one less column. So instead of being, right now we're looking at row 6, column 2. We would like to look at row 5, column 1. So why don't we do that? So we want to decrement the row, and we also want to decrement the column. Now to get the 10, we want to do pretty much the same thing, except this time we're not decrementing the column at all. We're still in column 2, and we're trying to get out of column 5. So we only decrement the row. And remember that to get this 15, we sum the 5 and the 10. So let's do that. Okay, and here we go. And then we would probably want to return this. So this is going to be how we're using recursion to solve our problem. Now, you may be asking something. Where are the base cases? Well, that's pretty much the next thing that we're going to have to work on. So let's work on the base cases next. Alright guys, so I pretty much took the liberty of just compressing this code a little bit with the slash so that it can fit on one screen. So you guys can read it while I'm talking. Other than that, let's get started on the base cases. But before we start writing code, I want to look back over here to this, I guess, this artistic rendition of Pascal's triangle, even though it's not very artistic. So let's look over here. So pretty much what you can notice from this, from these numbers is that at column 0, no matter what row I am, it will always be 1. So that is very important, and I'll get back to that later. And you can also notice that there are a bunch of zeros over here on the right side. Where does these zeros come from? Well, pretty much the zeros here comes from the fact that there are 2 zeros here, right? And you sum these up and you'll get 0. But where do these 2 zeros come from? They basically come from up here. So I guess this, you can call this the top axis over here. All these zeros are responsible for making all these other zeros, which is very important. Because if you want to have a 1 over here, this 1 diagonal, you're going to have a 0 diagonal over here. So it sums up to 1. But why am I pointing this out? Well, this kind of relates to the base case in that any point you pick in Pascal's triangle, you can keep on tracing it upwards, right? Like this. And then this 1 would have it, gets its value from here, and this 3 gets its value from here. all the way back up until somewhere you're along this grid. Like, let's say you're wondering how you got this 1. Well, you got this 1 from this 1 and 0. And that's very important because that's where our base case will create this line over here and create this column over here. And from that, we can get the rest of our triangle. So why don't we begin coding now? Okay, so now let's actually start coding now that we notice all these little facts. So like I said before, column 0, they're all 1s. So why don't I do that first? So if column is equal to 0, return 1. And that will give us this nice column right here. That's all 1s. Aleph rows is equal to 0. I should also return 0s over here. So I would like to return 0. So this basically creates this nice line we have here, and it's important that we do it in this order because if you do rows on top and the columns switch down to the bottom, then this top left corner would become 0 instead of being 1 because you'll run into a row case first and now set it equal to 0. Other than that, that's pretty much how you implement this function. And it may seem like we didn't do a lot of work for something that's pretty complicated. Like finding out this 15 here isn't that trivial, but with recursion, it's not too hard. You just have to set the base cases, which is making these two axes over here and over here. And then you have to look at how recursion is going to help you. And in this case, we can notice that the 6, or this 15, or this 20, they're pretty much just the sum of the numbers above it and the numbers to the top left, which is row minus 1 and column minus 1, or just the column. Okay, I guess now we'll just try to test this function. So as you guys can probably see, I wrote all these doc tests up here. So I'm just going to run them. So I'm just going to run python 3-m doc tests and then Pascal triangle.py. And as you can see, all the doc tests pass. And now I'm going to run a interactive section to show you guys that it's actually working if you're still not convinced. So I can run Pascal's triangle. And let's just pick any point. So let's say we want 3, 6. It would be 20, right? So 3, 6. Whoops, I meant 6, 3. You got to make sure you don't get the rows and columns confused. So you would get 20. And then even if I pick any random point over here, like row 3, column 6, so the other way around, it should give me 0. And you can see it does give me 0. And I hope that's enough convincing for you guys that recursion works and that you can trust it. And good luck with coding.